Are fairness matrix algorithms and do they change the model? Okay, so I'll start by answering what an algorithm is. An algorithm is a function of code or functions of code, okay? A fairness matrix is a function. However, a fairness matrix is not an algorithm. They are not algorithms applied to the model. So they do not change the machine learning model. See them as evaluators. They evaluate the machine learning model to detect any signs of bias. Okay, so they measure whether a model is behaving fairly across all groups of people, age, gender, race, etc. Okay, now fairness matrix are evaluating functions applied to a model to detect any signs of bias. They do not change the model, or they do not change how the model is trained directly. However, they can, if they are explicitly incorporated into the training process of that model, they can guide in training that model to reduce bias. And this is us getting to answering the question how we can reduce algorithmic bias in machine learning. Okay, so fairness matrix is essential in helping us get there. Now, before I go straight into answering that, why do we use fairness matrix? We use it so we can uncover or quickly uncover hidden bias in data and models, right? B, it helps us to be able to make ethical and responsible AI systems. And C, it helps in ensuring that our AI system can comply with legal and regulatory standards in policies like GDPR, EEOC, and the likes. Okay, so that's why we need to use fairness matrix or apply fairness matrix to evaluate our machine learning models. Now, going to how we can reduce bias in machine learning or reduce algorithmic bias in machine learning. Let's break the machine learning. We can break the machine learning process into three levels. Okay, so we can have the pre-processing stage, the in-processing stage, and the post-processing stage, right? And across all three stages, we can explicitly incorporate fairness matrix into them. Okay, so see it as, sorry, that's my mouse falling on my lap. See it as, sorry about that, a raw data, right, fed into the pre-processing process. Now, when you feed the raw data into the pre-processing process, what you're doing at the pre-processing process with that raw data is you're adjusting that data before you train that data. So you are ensuring that that data, the data you're about to train your model on, is quality data. Okay, so that's what happens at the pre-processing. At the in-processing, I will call that process if you explicitly incorporate fairness matrix into that in-processing, which is the part where you are training the model, right? I'll call that the fair training, ensuring that the training you are applying to your model with the algorithm is a fair training. And that is ensuring that you are incorporating explicitly into that training process fairness matrix as well. So that's what can happen in the in-process stage. And then the post-processing stage is where you are applying fairness matrix in adjusting the prediction after training. So you can evaluate your predictions on the using fairness matrix function to evaluate it, and then adjust your predictions accordingly as well. So applying fairness matrix across each stage of your training process is a way to reduce algorithmic bias in machine learning. Okay, so what are the three stages again? Pre-processing, which is where you're adjusting your data, ensuring your data is quality data before training. In processing, which I have tagged the fair training process, where you're applying fairness during your training, and then, or you're building fairness into model training, basically. And then the post-processing, which is where you're adjusting your prediction based on the evaluation on your prediction post-training as well. Okay? Now, let's then go into the pre-processing techniques. The different techniques that we could use. Reweighting. I'm going to write it down. I've always mentioned my R is horrible. Reweighting means you assign higher weight to underrepresented groups. Okay. So like I was using the financial history of different groups of people. Now, if for different groups of people, they have longer financial history because in our society today, that group of people, I'll put it that way, that group of people have had the opportunity to build financial history over a longer period of time. That means when you're getting financial history data, that data will be skewed in favor of that group of people by default. Because by the time you get to the other group of people, where by some reason, right, and we know some of the reasons, slavery and the likes, they don't have a longer history of financial transaction, the data will be skewed against them because that data set for that group is smaller compared to the other group. What you can do is you can assign higher weights to the group with a lesser amount of data, which is the underrepresented groups as well. So that is a technique that we can use during pre-processing. Remember, pre-processing is when we're adjusting the data, ensuring that the data we're going to use for training is quality data. Okay, so the technique we can apply at that stage is reweighting, adjusting the weight, giving higher weight to underrepresented groups at that stage. Another way we could ensure a better data quality and even set of data is by applying resampling. Okay, resampling means that we balance the data by oversampling minority groups as well. So you can apply resampling. A third way, which most people use, especially those doing thesis, a lot of academics use this process, is called synthetic data, right? Which is creating artificial data for the minority group as well. So basically you generate, so if say the data set across both groups is like 70-30, right? You need to make it 50-50, isn't it? So you have to be sampling the smaller group to ensure that, so you probably would take out 20% of the data of that other group, so making it 50, and then create synthetic data to bring the 30% of that underrepresented group to 50 as well. So you synthetically create 20% more data using the patterns of the minority data group. So synthetic data is you creating artificial data for the minority group to ensure an even data set with the other group that is heavily represented. So those are the pre-processing techniques. Reweighting, where you're adjusting the weight of the minority, giving them a higher weight for the minority group. Resampling, which is oversampling the minority groups, and creating synthetic data for the minority group. So those are the three techniques you can apply during pre-processing technique as well. Now, once you now have a quality data set, which is a balanced, even data set, then you move to in-processing, which is where you train the data. Now, in-processing technique, you can apply adversarial debiasing. So it's using two models, basically. Now, you have the predictor, which is the main task, and then you have the adversary, which attempts to identify sensitive attributes within the data set. Okay, now Adversarial debiasing is actually a function that can be applied during your training model. So if you apply adversarial debiasing to your training process within your algorithm, you ensure that you have introduced fairness into your training model as well. Okay? Now we go to post-processing. Now in the post-processing technique, you can then apply actual fairness matrix functions to your predicted data as well. Now remember, within the fairness matrix examples I gave, there's the demographic parity, there's the equal opportunity one. So demographic parity means that across all demographics, they always get the same positive outcome. Equal opportunity also ensures that they get true positive equally for all groups of people within that data set. Now I'm using the loan data set as an example because it makes it more relatable. Another one, which is actually a better fairness matrix to apply during post-processing, is the equalized odds matrix. And that is ensuring that the true positives and false positive rates are equal across all groups of data. Okay, so it adjusts the threshold per group and ensures that both true positive and false positive rates are equal across all groups. So you can apply the equalized odds fairness matrix to your predicted outcomes as well, which is part of the post-processing technique. You can also do reject option classification. Right, now that needs proper attention when you're applying that, but what it does is it adjusts the decision near boundaries as well. So it's called the reject option classification. So example, adjusting the loan approval rate across groups. Well, that needs proper data sciencey work around that to ensure that you don't end up then punishing the other set in favor of the minority group. You get? So yes, applying fairness matrix post-processing is a technique that you can apply to ensure that we reduce algorithmic bias in machine learning. So what is the bias detection workflow, right? So as you can see on screen, you have the raw data, okay? And then with the raw data, which you then in pre-processing ensure that there is a better data quality on them. You adjust the data accordingly. You then check if bias is found. If bias is found in your raw data, right, you then apply the strategies, which is the strategies that we've mentioned in pre-processing. Either you're reweighting your data, adjusting the weight for the minority group, you're resampling your data, or you are creating synthetic data. Once you have adjusted it and there is no bias found, you pass it to train the model, right? Now, while you're training the model in process training, you apply adversarial debiasing into that, right? That's the strategy to apply. And then it goes in circle like that to ensure it goes then straight back to from in-processing to post-processing. And then if you need any more adjusting, applying the strategies given. So for post-processing, you have the fairness matrix, like equalized odds, ensuring equal true positive and false positive across both groups. Once you keep ensuring that you are checking for fairness at every step of your training, then you have ensured to your best ability, hopefully eliminated any form of algorithmic bias, but you would have reduced algorithmic bias significantly. Okay? So that is in answering the question on how we can reduce algorithmic bias. Now, adversarial debiasing. The goal of an adversarial debiasing, which I would like us, again, I give us, because I'm sure this video is quite long at the minute, it's almost going to an hour now, but look into applying adversarial debiasing, the goal is to have a predictor and the adversary on the prediction become the independent agent that ensures that fairness is applied across the training process. Okay, so look into applying adversarial debiasing in your training process. So on screen is just data examples of adversarial debiasing on different groups, what the loan approval rate is before applying adversarial debiasing, and what the loan approval rate is after applying debiasing as well. So you can see by applying adversarial debiasing, you're closing the gap between groups and ensuring that you have an overall prediction outcome in the end. Now, can bias be totally removed? Quickly, just to round up. The aim is to totally remove bias, but there is also the question of fairness versus reality. I gave an example that in reality, that a certain group of people may, of no fault of their own, have a lot of data available compared to another set of people, and that's the reality, right? So it's not a case of fairness versus accuracy. In the sense, it's also ensuring that we're closing the gap between the reality of the data set to ensure that there's fairness as well. So perfect fairness is challenging. Balancing fairness and accuracy is also quite challenging because you have to balance fairness with reality as well. But the best way is that we go into ensuring that we're constantly evaluating this system, ensuring that a group of people are not punished due to no fault of theirs. Okay, so we should seek to ensure fairness. So continuous monitoring of these models would ensure that we can all be fairly, we can all experience fairness in these AI systems. Okay, so we should ensure that we're constantly monitoring the system, evaluating them for fairness across all groups. Now, tips for better data quality. Again, audit regularly. You must constantly audit your system, your data. You can use AI Fairness 360. There's Fairlane. There's a lot of libraries out there that we can apply to our data, especially the entire machine learning process I've given us. Remember, if you divide your machine learning process into 3 stages: pre-processing, in-processing, and post-processing, you can apply fairness at every stage of that, successfully. Ensuring that we have diverse teams, okay? Ensuring that every group of people is represented while building that system as well. Transparency, document what we've done. Because transparency ensures that we can, because sometimes it's called unconscious bias, right? These systems are not built intentionally to be against a certain people. It's just that unconsciously we might have recruited a certain type of people to review the data, and they are skewed to a demographic. Do you get? So ensuring that the process of your machine learning or machine learning process is documented properly would also help identify any gaps, right, in that training process, right? Which includes, do you have a diverse team? Was fairness checked at all levels? What were the outcomes at the time? What's the audit on the system as of this date? Constantly monitoring the system, documenting what we've done ensures that we can have better data quality and reduce algorithmic bias overall. So it's an intentional thing. We must want to reduce algorithmic bias. Okay, if we want to reduce algorithmic bias, we will put system in place to ensure that at every stage of machine learning or model training, we have implemented fairness metrics, functions, adversarial debiasing at every stage. Okay, and that way we will eventually reduce or finally eliminate algorithmic bias in our AI systems. Okay, in conclusion, machine learning can significantly reduce algorithmic bias by ensuring that every stage of model training we implement fairness matrix, resampling, reweighting, whatever method we choose at all the stage of training that machine model, right? So by following that, we are able to reduce or eliminate algorithmic bias totally. Okay, it has to be intentional. It has to be intentional. We must want to reduce algorithmic bias. So yeah, that brings us to the end of this episode. Please like, subscribe, comment below. If you have any other techniques that I haven't mentioned, we're all learning here. Please, I like to learn as well. Okay, please put that in the comments. And as usual, participate in this community. If you want me to expand on anything around machine learning or AI or any topics that you do not understand and you want me to shine more light on that, please let me know as well. Okay, thank you for your time today, and I'll see you next time. Bye.